Hi, welcome to a product review by watthour. In this video we are going to do the review of this PeaceFair PZEM-015 and PZEM-013, which is a 0 to 200 volts DC and 0 to 300 ampere in the range of 10 ampere, 50, 100, 200 and 300 ampere power, voltage, current, energy and capacity meter. I'm going to explain the module, the features and how to set it up. After that I'm going to open it when we will have a look at inside of this. Then I'm going to show you how to wire it. After that we are going to talk about battery and voltage of the battery, and then we are going to test the current up to 100 ampere, and then we are going to power it up with a battery and also check some parameters of the battery and drain lithium iron phosphate battery. Let's get started with this. Now let's open the box. This is how I received it when I purchased it. When we open it, you see the first thing that we see is a shunt resistor. This is a 100 ampere and at 75 millivolts, and there are different versions of it. 50 ampere, 200 and even 300 ampere is sold, whichever you pick. And here there are some wires to connect it to the shunt and also to the actual device. The package is very cheap. They just put it in a bag, but hey, as long as it works. So this is the actual module that you can see. One push button, nothing else. Very nice diagram. Connectors are looking very nice. You don't need a screwdriver. And here, this is a manual, English and Chinese, full color with diagram and details. And that's it. Length of the module is where this is the length where you insert it in the panel. The length is 84.6 millimeters and the width is 44.3 millimeters. The depth is 24.2 millimeters. And if you want to know the external width of the module, 89.7 millimeters, and the width is 49.4 millimeters. Now let's have a look at the specification for this PeaceFair PZEM-015 and PZEM-013. If you purchase PZEM-013, then it will have 10 ampere built-in shunt. There will not be anything external, just connect the wires. But if you purchase PZEM-015, then you can have shunt for 50 ampere, 100, 200 or 300, and then you will select the option which I'm going to show you to select your shunt, and it will work for all of them. And operating voltage, it needs 3.3 to 12 volts for the display to work. And for PZEM-013, the current is 0 to 10 ampere, and the minimum resolution is 1 milliampere. On the screen you will see 999 milliampere range or 9.9, whichever the value is. It will fit within these two range up to 10 ampere. Accuracy is 1%, and for PZEM-015 the current is 0 to 300 or 50 or 100 or 200, all those values, and the range is 1 milliampere, and the values will fit within those ranges that we have. For example, 9.9, 99.9 and 199 and 299 for the 300, and for the 50 we have 999, 9.9 and 49.9. For the voltage, the maximum measuring voltage is 200 volts, minimum resolution is 10 millivolts, and on the screen you will read either these ranges to display the voltage. For power, the maximum is 20 kilowatts, and depending on the version it will change. Just multiply voltage by current, and 10 milliwatt is the resolution, and these are the ranges that you will see on the screen. And for the capacity, 0 to 1000 ampere hour and 1 milliampere hour will be the resolution, and these are the ranges that you would get on the screen. For the energy, it's about 10,000 kilowatt or 10 megawatt, and minimum resolution is 1 watt hour, and these are the ranges that you will get. 9999. And for impedance, 0 to 1000 ohm, that is the load impedance or resistance of the load. Minimum resolution is 10 milliohm, and these are the ranges that it will show. And for measuring internal resistance for the battery, these are the values from 0 to 999, and with the minimum resolution of 10 milliohm. And the range will be on the screen up to 999 in terms of milliohm. When the time runs, it will be up to 999, 1000 hours, and 999 minutes and 59, so that is 10,000 minutes, less than a minute. And for state of charge, this is an approximate method that they have used. So they say how the calculation is done internally. It gets the maximum voltage that you're reading from a fully charged battery minus the minimum voltage, whatever is the difference, divided by 10. That will tell you state of charge, and based on that it will move the bar on the screen, the bar graph. Here on the screen we have here the voltage will be displayed, the voltage that you're measuring, and then the current. The unit will change. This shows now millivolts, it will change to milliampere, it will change to ampere, and then watt also will change to kilowatt depending on the value. So voltage, current, power, and then this is energy, watt hour, WH. On this screen we see capacity, it shows 20 ampere hour. This is a test that I have done. The external resistance or the load resistance, this will be Ohm's law, R is equal V over I, so this V divided by I. And then this is the internal resistor of the battery, it will measure it for you, and this is the time that it runs. This bar graph here is for the battery capacity. This battery capacity depends on the settings that we do for our battery maximum charge voltage and minimum cutoff voltage. So based on that, the bar graph or state of charge will be displayed here. Push button here, when you press it, it will turn off the screen. So for some reason, if you don't want to see it or save energy, and then it will just turn it on. But the device is on, it will just turn off the screen. At the back we have these wires. The connectors are very easy, you don't need any screwdriver. For this you just hold it and invert it, it will hold it for you. So we have two for the power, positive and negative, and then for the battery voltage we need positive here and negative. So two wires will go in here, that is for the battery. And for the shunt we need two wires, so that's why we have 6. These two from the shunt will be connected to these 2 points, so we can read the current as a voltage, because this is a shunt resistor. As the current passes, we will have voltage appearing across this resistor, and we are reading it. And this is our load. So I'm going to show you and explain the wiring for charging or controlling the state of battery. Because the battery charger will charge certain battery. This battery is 12.8 volts, the nominal voltage. This has minimum and maximum, so the charger will turn it on and off based on minimum and maximum. And for this one we have, for example, this is just an example, and it varies from battery to battery. For example, 14.4 volts, and the cutoff current for this one is, in terms of voltage, 11.0 volts. We have to monitor it accordingly. That's why we need minimum and maximum, these two values. And on the screen we can see only 3 digits, not 4 digits. So if you want to set 12.4, you will see you have to set it as 0.124. So this 0 is for third digit in case you have 120 volts or something, 130 volts, whatever. We have to set it properly. So the blinking will start from one digit and it goes to the next one. Then when it reaches to the next one, we can see only 3. The dot and 0 point will disappear. So this 4 or whatever number you have. So we can see only 3. And that's a little confusing. So I made this presentation so you can see it. Now, for example, when you come, you will see the 2. We will set it to 2. For example, this 2 is for that 2. And when you press the button again, it moves to the next one. And this 0, you can now press it and change this 0, 1, 2, 3 up to 9. And if you wait, the blinking will move to the next digit. So for example, from one to the other, it goes without anything. Just leave the button untouched and it will move to the next one. Now we see the 0, this digit, but this 0.4 has disappeared. Just an example. So now we can press the button and change this to 0 if it is something else. After that, it goes to the last one. Now the 0, which was here, disappeared, and then 0.4 appeared. So we can press the button to change it. So we can set it 12.4 as 12.4. So here I'm pressing and holding it. When you see this screen, again press and hold. Now we are on the last digit, and then you see it rotates, it goes here. Now that disappeared. Now the third digit on the left appeared, so it just rotates. Just wait. So let's change it to 1. I want to make it 12, so that 1 is needed. Do not worry about 8 because it rotates back. So 4 is good. Now I'm waiting for this, and in here I'm going to make it 2. Oh, I missed it. So 12.4. Oh, again I missed it. Make sure at 1 and 2. So when this is done, press and hold it for a few seconds to exit. Now this bar graph changed. Now we are at the cutoff or the lower voltage. The same way if you want to set it for 11 volts, we will set it 11.0, and the blinking will start from one digit. For example, this is 1. It has to go to the next one, so we can set it to 1, so that is 11. Then it goes to the next digit in here, which is now empty. So we have to set it to 0, and it comes back to the last one, this 4. Then we can set it to 0. So now it's let's set it to 1. That's our digit, and now the last one should be 0. That's okay. Now this one I want to set it to 0, and it goes to the next one, 1. So that is 11. It goes here, and then next digit, and it rotates. So we have set the value at the cutoff voltage at 11, and just hold it to exit. So now we have successfully set the voltage. You get it, you will have different types of shunt, 50, 100, 200, and even 300 ampere shunt. For that, let's set this shunt. We have to tell which type of shunt resistor we have. So hold it until you see the blink, and then press it. It will come here for current. Now hold it. So this screen will stay. So now no worries. Now it's 100, press it, 50, 200, 300, it just circulates and comes back to 100. Because we are using 100, I'm going to leave it at 100, and then hold this to exit. Now this will read proper current because we set it to 100. The energy shows 36 milliampere hour. We want to reset it. These 3 values can be resetted. This energy, because it is depending on time, milliampere hour depends on time, and then the time itself. So these 3 values can be resetted. Hold this button and then press it once, twice, and you see clear. Now it is for this. If I hold it, so that got resetted. So if I come here, just hold it, it got resetted and it returned back. And if the time is needed to be resetted, the same way, go to time, press it until you see the time, and then hold it. It will be resetted and exit. So one thing that I noticed, for the counter will start only when there is current. When the energy starts draining, so the counter will start. That is nice, so you don't have to worry when it is on, it is not running. So here I'm just connecting it in here, and as you can see, it shows the voltage. So this is just a voltage based on the value that we set. Remember, our voltage is 12.4. So based on 12.4, that is 12 volts is showing, so you know the state of the battery. That's also nice. Now let's open it and see what is inside. So this is exactly like the previous module, and this is the PZEM-015. So here, if we compare them with this model, as you can see, this chip has changed, the display driver, and the rest is exactly the same. And if we open it on this side, this is how it looks from inside. Let's have a look at the component. At this chip first, and that is 2N60C. This is a MOSFET. Let's have a look at this display driver. This is driving this screen, and as you can see, this is TM1622. That is TM1622 32x8 LCD driver. I couldn't find the English version. Let's have a look at this chip. MXM1162P. Here, the MXM162P. This is microcontroller with analog to digital converter and LCD driver. Let's have a look at this chip. And as you can see, this says K24C02, and here it says 2-wire serial EEPROM. That's erasable, electronically erasable, programmable, read-only memory. And let's have a look at this. Maybe it's a voltage regulator or transistor. And this is 7133. Here's a data sheet for 7133. So this 33 is referring for 3.3 volts. This is 30 milliampere, low power, LDO, low dropout. And as you can see, input voltage is 24 volts. So it receives 24 volts and outputs with different voltages that XX refers. And here we have 133, that is 3.3 volt version that we have on this module. The most important component, this is a diode, just protected in case if you connect it in reverse, the polarity. We need two power. One to power this meter up so it is turned on. In that case, we are using these two pins, 3.3 to 12 volts. And that is done, so this will power up the meter. Now for the voltage of your power supply to measure and display the voltage, then we need to connect the two wires here. The positive is to the last one, and then the black goes to the second one. Now at the middle we have yellow and blue. Yellow and blue will go to your shunt resistor, and if you're using PZEM-013, you don't need to connect it. It is these two wires will go directly to your load. In our case, because we are using shunt, so the yellow will go in here, and the blue will go to the next one. So my wiring is now complete. This goes to my about 8 volts power supply, and this goes for the battery or my power supply that I'm measuring the current with this. Now for your load, it will be very simple. From negative, bring it to the shunt, and from shunt, take it to the load. And then from the positive of the battery, just bring it in here. So instead of connecting the negative directly to the load, it goes to the shunt. So it comes to the shunt and passes. Now let's do some tests. Now I've connected it. This is my cable connected. So very thick cable to the 100 ampere shunt, the module, the display. Now I'm going to draw 1 ampere, turn this on. So let's turn it on, and the current is now 1 ampere. So here you're reading the voltage and the power. So the power shows 12.4 watts, 1 ampere. So here it shows 989 milliampere, very accurate. Let's go with 5 amp. So now it's 5 ampere, 4.95. Wow, this is amazing. Very accurate. We read 61.1 watt, and here 61.7. Some deviation here, even though the voltage is shown 12.3, and the voltage with the sensing, I've turned the sensing on, meaning there's no drop on the line, voltage drop. The power is calculated with some deviation. Let's go with 10 amp. Now I put it at 10 amp, and as you can see here, it shows 9.9. So 100 milliampere deviation. Still the voltage is the same. These calculations that you see are, these two are not relevant. But amount of energy is relevant here. And if it was a battery, this would have been also a capacity. Because this is watt hour, you will see it will move very slowly. Let's go 20 amp. So now 20 ampere is being drawn, and as you can see it shows 19.7. This 12.2, like 100 millivolt, is from my power supply. My power supply also shows at the moment 12.2. So let's go with 30 ampere. So now 30 ampere is being drawn. You see 500 milliampere deviation here. So it shows the incorrect, like by 500 milliampere difference, and the power 64 watts, and here we get 358 watts. Now let's go with 40. Now the current is 40 ampere here, 39.7. So this is 300 milliampere, which is very minimal with this large current. Acceptable, 483 watts and 486 watts. That's the voltage we are reading, and this is the voltage on the precise lab equipment. Now let's go with 50 ampere. So now this is exactly 50 ampere, as you can see, 605 watts because of this deviation in voltage. So we are reading here 602, and here we are reading 605 watts. This is amazing. Do not worry about this bar. This is related to the voltage setting, which we are not doing now on the battery. Now let's go 60 ampere. Now we are drawing 60 ampere. $722 watts, and here it shows 720, only 2 watts deviation. It seems when we increase the current, this became more accurate. The ampere is being drawn from this shunt. I'm using a thermal camera. The link for this camera is below the video in the description. So let's have a look at this and see how hot this is. Here the shunt resistor is now let me just show you to test lithium iron phosphate battery. For one battery, this is a 100 ampere hour battery. The nominal voltage when you do the calculation or looking at it is 3.2 volts. So this is called 3.2 volts battery. But the charging voltage is 3.65, the maximum voltage. And the cutoff voltage for this particular battery is 2.5, and you have to look at the data sheet for specific battery that you're purchasing, so you know for each cell. In this case it's 2.5. So now we want to see that we want to put 4 of these in series. To put them in series, this is a negative, so positive of 1 goes to the negative, positive of 1 goes to the negative, positive of 1 goes to the negative, so we are left with a positive. And 3.65 times 4, we need to charge these batteries at 14.6 volts. Cutoff voltage is 2.5 volts, so that is 10. And here for nominal voltage, 3.2 times 4 is 12.8 volts. So all the batteries that you see labeled as 12 volts, that is 12.8 volts. A battery, 4 cells have been arranged internally in the package. And here now I have these 4 lithium iron phosphate batteries, the 4 with 100 ampere hour, minimum at 10 volts and maximum is 12.8. So I'm pressing this button here and holding it, and then holding it again, releasing and holding it. So 12.8, rest, oh, changed. Let's make this 12. Wait for it to go to the next one, and it goes to the next digit, and then it comes back. So I'm going to make this 12.8. Now hold it. This empty means the cutoff voltage, and the cutoff voltage is 10 volts. So let's wait for this, the last digit, and it will rotate back. So let's make this 0. I missed it. So 10. Now let's hold it and exit. Now the same voltage that is here. You can read it here. The current is at the moment 0, and let's go with 5 ampere, for example, if you're using a battery. And then let me turn it on. 5 ampere. So now it shows as the voltage drops, it calculates proper value for the power and capacity. If we want to reset it, let me reset, turn off this first and then reset it, reset all the values. Now this shows 12.9 and this shows 12.25 because I've disabled the sensing. Now I'm activating remote sensing. Now it reads very accurate value. Whatever you see here, 12.8, and we are reading 12.8 because I've activated remote sensing. It shows almost 0 for the battery. So the battery, the meter, this is one is for the sensor, sensing the voltage for my electronic load, and the other is for the meter. 100 ampere. Now 100 ampere is being drawn from this battery, and look at the voltage. The battery is being drained very quickly. With 100 ampere, the voltage, the bar graph for the battery is perfectly functioning, and this is amazing. It shows internal resistance of the battery, 9 milliohm. Shunt resistor shows 60 degrees Celsius. (85°C) actually. Actually the shunt shows 87 degrees, so it got very hot now. You see 95. It got very hot. So now for conclusion, I would say that this is amazing device in terms of accuracy and measurement and features. However, if you want to use this shunt resistor, or if you're measuring 100 ampere, I would suggest getting 200 ampere. Maybe you will have a little error on the reading because it's 0.5%, but still you will have less waste of energy here. As you saw, this was reaching up to 95 degrees Celsius, was getting very hot. Other than that, setting, especially this connectors that you don't need even a screwdriver, you can just disconnect them. This is amazing, and also they put directly diagram here to make it easy. So definitely I recommend this. I've purchased it from my own money. I will provide you the link below this video if you want to buy it from AliExpress or Banggood or Amazon. Make sure to put bolts for all higher current above maybe 20 amperes. Use all this type of connection. It should be very solid and very thick wire. Thank you for watching. This was the review of this PeaceFair PZEM-015 power, voltage, ampere, capacity meter, whatever you call it. That's a multifunctional device, and it's very accurate, especially with the higher current. Please thumb up the video and share it, and make sure to subscribe, as I will do a lot of battery testing with a lot of analysis and properly explaining and testing different batteries. In this video, we are going to do the review of this 50 volts, 20 ampere Wurji WZ5020L back converter. 20 ampere or 1 kilowatt. We're going to test it with different voltages, up to 55 volts at the input and up to 20 ampere. Needs more current, so the constant current is turned on, but we are not worried. Input current 10.8,